Hi everyone, we're going to graph a polar equation called the Limaçon. If you're French, it's probably Limaçon, something like that. I'm from Texas, so bear with me on that. Okay, so we're going to graph this one here, and it has this form where A is bigger than B. So my 3 is bigger than my 2. And the first thing, of course, we want to do is do the 3 tests we have to do. So the first test we're going to do has to do to see if it's symmetric to the polar axis, which is basically your x-axis. And how you do that is you replace your theta with negative theta. So you get so replacing theta with negative theta. If we get back to our original equation, then it is symmetric to the x-axis or polar axis. So when I put this in, we know that cosine is even. So we can just take that away and make it a plus. So yes, it does pass the polar axis test. So it is symmetric to the x-axis or the polar axis. Okay, the next test is the line theta equals pi over 2. So that just means it's symmetric to the y-axis. And what we do is replace theta with pi minus theta. So I'm going to write this equation. And we're going to use the difference with the cosines that you learned in trig. So this would be cosine of pi, cosine of theta, plus sine of pi, sine of theta. And what we get here is, if you simplify, you're going to get 3 3 plus 2, this is negative 1, and this is 0. So we're going to get negative 1 cosine of theta, which gives us 3 minus 2 cosine of theta. And that equals your R. And these do not match. It does not match that. So the test fails here. And all that means is that it's sufficient to say it fails, but it still could be symmetric to the line, but probably not. Okay, and then the last test is really easy. Since we don't have an r squared, basically we're going to test if it's symmetric to the origin or the pole, and you replace r with negative r. So, and when you do that, of course, you can't do anything. The only time this will work is if your r is squared, which we'll see in another video. So the test fails there. So basically, now that we know that it's symmetric to the polar axis, which is actually the x-axis, I know what table to set up. And I set up my table from 0 to pi, so that on my circle, I'm looking at the symmetric to the x-axis or polar axis. Alright, and I plugged everything in already to save time, and I got my points here. So basically, we're going to try to graph this as good as I can graph, and I'm just going to graph it on the top here of the x. So basically, I'm going to graph it on the top here. And again, this is r equals 3 plus 2 cos of theta. So basically, I'm going to start with pi, and pi goes to 1, and I'm going to scoot it out a little so you can see it better. So my 1 is going to start here. Maybe not, because we have to go all the way to 5. So I'm going to go ahead and put my 1 here. So at pi, we're at 1. At pi over 6, we're at approximately 1.27. So a little bit out here. And at 2 pi over 3, we're at 3. So at 2 pi over 3, we're going out 3. 1, 2, 3. And I have to be careful what I'm writing here, so, all right. And then at pi over 3, we get 3 again. Actually, this was 2. I messed up. I knew it looked kind of weird. This goes to 2. And then at pi over 3, which is here, we go out 3, 1, 2, 3. And then at pi over 6, we're at 4. So we get 1, 2, 3, 4. And then at 0, we're at 5, which is here. So I'm going to draw it. Kind of goes like this. Now, since I know it's symmetric to my polar axis here, I can just infer the rest. So 11 pi over 6 is going to go to 4, 2, 3, 4. My 5 pi over 3 is going to go to 3. So it's going to be 1, 2, 3. And then as we get closer in, we have, let's see, 4 pi over 3 is going to go into 2. And then we get closer in here. So we go here, and it kind of goes out. So it's kind of like this. Again, I'm not very good at graphing, but there it is. All right. That does not have an inner loop. And so the basic information about Limaçons or Limaçons is this. These are your formats, because you're going to have to determine later on which, you're going to have to be able to look at it like you do with conics. So we know that A has to be positive, B has to be positive, and A is greater than B, or A is bigger than B like ours was. These Limaçons without the inner loop do not pass through the pole. And one more note I have here. I looked on Wikipedia just to make sure I knew how to pronounce this, which I still don't. But anyway, they gave this equation here, and they have this animation where they have the circle here, and this is radius of 1. And then you go out here and draw this other circle right next to it with the same circle. And if you rotate the circle like a roulette around, it yields, and you have this point right here. When you circulate counterclockwise, you get something like this. And that's the Limaçon, the red one. So I really suggest you looking at this. It just takes a second, and it's very interesting, and it has information more about the history of the Limaçon. Thank you, and have a nice day. The next one we're going to do is the Limaçon with an inner loop. Bye-bye.